Hi, my name is Carmela Beiro. My Twitter handle is Carme Beiro. I will be posting the slides afterwards. It's going to be my first Twitter post. I'm a data engineer at Octobot Dev, that is a software development consultancy. We are based in Montevideo, Uruguay. Uruguay is a small country in South America, next to Argentina and Brazil. We are about 3 million people. It's a really small country. And well, some of my hobbies or passions are reading, animals, doing workouts such as yoga, and traveling. Okay, well, it would be ideal to, at the beginning of a project, know all the response time issues that we are going to have, but we all know that that is not possible. First, because we cannot foresee every single issue that we are going to have, and second, because we don't know how the data is going to be in production. So the idea of this talk is to present, well, what steps have I followed in the different projects where I had these issues, and also what considerations to take. So in order to present the different examples, I'm going to use these two models. We have recipes that have a name, instructions, they have an author, a category, the difficulty, and also if it's active or not. And then each author has a name and an email. Okay, so once we have an issue in production, what can we do? Well, we could use a profiling tool. The idea of these tools is to provide a way to know which part of the code is being executed, how much time is taking to execute, and also the SQL that is being executed. So I'm going to present two tools that we used over the years. Probably there are more, but these are the ones that I know. The first one is Django debug toolbar. This is used in Django admin. It appears like a sidebar. So you can see for each page that is loaded in the admin, which are the SQL code that is executed, if there are any signals that are being executed as well, and if the cache is being used, and you can also profile Python code. This was really useful because we had a client that the first request was to analyze why their Django admin was taking too long to load when listing a certain amount of instances of a model. They had around 800,000 instances, and it was taking approximately 15 seconds to load. So the first thing that we did was install Django debug toolbar to determine what was the cause of that bottleneck. So we realized that they had a filter that was, it was a multi-select filter that it was loading all the related instances to each of those instances of the related model, and that was taking a lot of time. So we replaced that with a search box with an autocomplete to only load the ones that were filtered by that criteria, and that helped a lot. So I really recommend this because it was really useful for us. Another tool that we find useful is Django Silk. This is mainly used for requests, so we use it in our integrations with Django REST framework. They provide an initial screen where you can see which are the requests that are taking longer, which is the SQL that is being executed, and you can also see, well, particular requests, the SQL, and you can also profile Python scripts. They provide a decorator to use in functions or model functions as well, that you can analyze the dependencies that the code has, and, well, which part is taking longer. So one note about these tools is that they are not meant to be used in production because they add an overhead when loading the admin or performing a request. So the idea is to use them either in development or in staging. Okay. Once that we detected what the issue is, another important thing is understand how Django works behind the scene. Not only for fixing a bug, but also when development, it's good to have these things under consideration. So the first thing that I wanted to mention is that query sets are lazy. This means that you can change any operations in the query set, such as filtering, excluding, union, distinct, order by, and those queries are not going to be executed until you need the data, so until you need to evaluate that query set. When does that happen? Well, for example, when you need to loop through a query set, when you need to calculate the length, like I'm showing in the example, when you need to check with a Boolean condition if the query set has any values inside, or for example, when you do slicing. In this example, I'm doing some sequential operations that are not triggering any database calls, but then when the length is calculated, a database query is performed. So until I don't need it, the query is not performed. This is useful to know because if we order the operations correctly, we may avoid unnecessary database calls. Another important thing is that Django caches query sets and attributes. So when a query set needs to be evaluated, what Django does is it first checks if the cache already has the query set stored. If not, it performs the query and then stores the result in the cache. So then on the next evaluation, instead of querying the database, it uses the results from the previous cache. In this case, I'm performing the same operations. I'm checking the length. That is going to check the database because I don't have the data already stored in the cache. It's going to store it. And then when I'm going to perform the loop, the data is already cached, so I don't have to perform another database query. Well, there are some cases where after evaluating a query set, the data is not stored in the cache. When does it happen? When I'm checking only a portion of the query set. For example, when I need to access an index, a specific element, or when I'm slicing. So in this case, I switch the order of the length and the loop. And since I'm performing a slicing in the recipes, that is queried, but it's not cached. So there is one database call, and then in the next one, since I don't have the data in the cache, the query is going to be performed again. So in this case, if the order is the same to us, it may be more performant to perform the length before the for. Another important thing here that I did for the example is I moved the order by below the length. So in this case, I perform the length, the data is stored in the cache, but since I performed another query set operation, Django needs to query again the database for the loop. So this is important as well. For me, the order by doesn't affect the length, so it's better to define it at the top and not afterwards, so I can avoid another unnecessary database call. Okay, since Django provides different ways of performing the same operations, it's important to determine which is the best way. Almost always, the best option is to perform operations at the lowest possible level. In this case, between Django and Python, between the database and Python, it's the database. So in this example, I'm trying to determine if an author has recipes. In the first example, I'm checking with a Boolean condition if an author has recipes. This is using Python. In the second example, I'm using exists that is going to query the database. So in these two cases, it's best to do the second option. But it's not that simple, because if I know that I will be querying, evaluating the query set, it's better to do that as soon as possible. So then I can perform Python operations instead of querying the database again. So to show you this, I created this example where I changed the length for the count. So instead of doing it in Python, I'm doing it in the database. That is performing a query. It's not storing it in the cache because I'm not querying the whole query set. And then when I do the for, I need to query the database again. So in this case, I know that I'm going to evaluate the query set because I need it for the loop. So in that case, it's better to perform the len operation that is going to bring it into cache and then perform the loop. And in that case, I will be having only one query to the database instead of two in this case. Another important aspect is how Django fetches related objects. This was mentioned in other talks, so I will be a bit I will pass this a bit quicker, but inheriting your database queries and the Django admin is your oyster, they mentioned how this works. So in this example, I want to get all the authors related to recipes. Let's see how Django handled this query. Well, so as you can see, there are a lot of queries. The first one is selecting all the recipes, and then there is one query per author per recipe. So I had 4,000 recipes in my database, so this is going to perform for 4,001 queries. So this could be pretty inefficient when we have a lot of data. So what can we do to avoid this? Well, Django provides two methods, prefetch related and select related, that lets you prefetch related objects. So select related works for foreign key relationships, and prefetch related for many-to-many. What select related does, it performs a join between the two related objects, and it performs only one query. Prefetch related performs two queries, one to get all the recipes and another to get all the authors related to the recipes. So in this case, I'm showing what's the query executed when I perform a select related with the author, and you can see that there is only one query that performs an inner join between the author and the recipes. So instead of doing 4,001 queries, I'm doing only one by using select related. Okay, once we had detected what the issue is, and we had determined that the order of the evaluations and the operations in the query sets are correct, and we are doing everything in the most efficient way, we can check how the database is executing our queries. In particular, if any indexes are being used or not, and if we need to define new ones. So in order to define an index, the most important thing is to determine which are the queries that are going to be executed. So it's essential that the developers that work with the database are the ones that define this. After we define an index, the query optimizer, that is the one that decides how the query is going to be performed, not necessarily is going to pick the index that we define. And this could happen because of two different things. The first one is that the query optimizer uses statistics to determine if it's more performant to select the index. But it could happen that our index is the best solution, but we haven't defined it in the correct way, so the optimizer is not picking it. And another important thing is that adding an index adds maintenance costs. So every time we need to create, update, or delete an instance that is related to an index, we need to update that index, so those operations are going to take a bit more. So that's where the cost appears. So the best thing to do is to define the less amount of indexes to cover the greatest amount of queries. So now I'm going to show you some things that it's good to have into consideration when defining indexes. The first one is that index orders matters. So let's consider that I have a web app where my users need to select a category, and then they have a search box for entering the name of the recipe. So when they enter the name, I need to search all recipes that starts with that string. So in order to do that, I decide to create this index that has the name and the category. Since the start with operation is performed with a like operator in Postgres, that is the database that I'm using, I need to define the op class for the name and say that the name is varchar pattern ops, and that's the only way that Postgres is going to be able to perform like operations with the index. So let's see how the query performs. What I'm doing here is I'm filtering the recipes that start with soup and has the category breakfast, and I'm explaining, I'm selecting explain, that is an operation that Django provides to see what the query optimizer is doing. Here I can see that the index scan is being used, so that's great. Let's see what happens if now I decide that I only want to query per category. Well, we can see that a sequential scan is being used, so the index it's not being used. what happens? That the index order matters. So if I define my index as name and category, I can only use the index for querying name or name and category, but not category alone. It works like a phone book. So you have ordered your phones by last name and first name. You can query it by last name, but you cannot query it by first name alone. So it's the same thing. Okay. Another thing that could be useful is defining partial index. So it's a way of adding a where condition in your index for a condition that is applied almost every time when you are performing a query. So in this case, most of the time I want to know which are the recipes that are active. So what I did is Django provides an option for defining a condition that is like a where condition where I select all the recipes that are active. This could improve the performance of the queries because my index is smaller because I'm considering less rows, so this could be more performant. Another thing that is really important is trying to select only the attributes that I'm going to use. This is important because this is going to consume to get less data from the disk, and also when performing operations, I'm going to have to consider less data, so probably it's going to be more performant. And the other thing is that the probabilities for being able to use an index-only scan are bigger if I only use less attributes, because if my index has the same attributes as my query, then the index can be used alone to get all the data, and you wouldn't have to check the tables in the disk. So this could improve everything, the performance a lot. So Django provides two ways of selecting only a small portion of amounts in a table. The first one is values, where you indicate the attributes that you want to use, and it returns a query set with dictionaries inside. And then the other two options are using only and defer. Only selects the attributes that you want to query, and defer the ones that you don't want to query. And it returns a query set with less amount of attributes. So then you have these two options. You can decide which is the one that fits best your requirements. Okay, what happens if I check everything and I still need to improve the performance? Well, what we have done in the past is, first of all, using caching. Django provides a decorrector for functions for caching the results. So when the operation needs to be performed, Django first checks if the results are already stored in the cache. These stored results are going to be valid for a certain amount of time. And once they expire, they are going to be removed from the cache. So if they are not stored, the function is performed, the results are stored, and the next time I perform the function, maybe I can use the results that are already cached. This is going to improve the response times, but it's going to have a trade-off, that is that the results are not going to be valid for a certain amount of time, the amount of time that I define for the results to be valid. So that's something to consider. Another thing that we found useful is to store pre-calculated results. So for example, if we have a report that has to do some complex calculations and has to do some aggregations, then what we have done is, with a salary job that runs on a schedule, we calculate the results and we store it either on the database or maybe in the memory using memcache or Redis. And we already have that available when the user needs to query it. Again, there is a trade-off, that is that the results are not going to be valid, not valid, but the results are not going to be up to date between the period of time that the job runs. Another option that this depends on the requirements of my project is I could return results in an asynchronous manner. So for example, I could say to the user, okay, I'm calculating this, I would send you an email once the results are ready. And the other option is, well, I would send you a notification. Again, this is not always possible because of the requirements in our projects. Well, and then another important thing is that maybe the type of database that we are using is not the best one for our requirements. So for example, If I'm if I'm always querying data related to time and I need to perform calculation based on time, maybe a time series database is more useful than a relational one. Or, for example, if I need to query a lot of historic data, perform analysis and aggregations, a columnar database is more useful. So one needs to check the requirements and see which is the database that performs the best in these scenarios. So here there are some useful links. The Django documentation that is very good, that lists all the steps that I mentioned and explains how the query sets work behind the scenes. The two tools that I presented, Django Debug Toolbar and Django Silk. And last, there is a book that explains indexes and all the things that I mentioned and more that is really good, that it's nice for checking. Thank you.
Yeah, I had a question about the setup for when you would not want to use the async. The only thing I can think of is if you're not using ASCII, right? And if you're not using ASCII, then I'm thinking you can't use the async approach to fetching the data.
So what happens if you cannot use an asynchronous approach?
I guess, yeah, I mean, the question is, yeah, if the requirement is to want to async fetch your data, right? Then I guess what are the requirements so that you can be guaranteed that you can use the async when retrieving the data?
The requirements in Django or in general?
I've decided on using Django.
Yes.
So based off of that, yeah.
Okay, so you should return a response if you are for example, using a REST framework. You just return a response, and once you can use Celery, for example, to trigger a job to run the results, and then when that is finished, for example, send an email with the results. You could do that.
Does prefetch related and select related work if, I understand if it's a relationship, but what if you're chaining things? The
More than one relationship, yeah. You can prefetch the other related object.
Oh, really? So you can do. So it doesn't have like a depth level of how low or.
I'm not sure. I'm not sure. Maybe yes, but I think you can chain at least two, for example.
Okay. Thank you.